in the last day we have started with the ECG signal. Now, ECG signal even for the same person, if we take it that it may be different acquisition, it is not just that we are taking the signal at different time. So, the signal would be different, but if different people acquire that signal, it could be different as well. The reason is there are number of configurations through which this signal can be collected. So, today we will know about the lead configurations, which also determines that how the ECG signal will look like. So, now let us look at that first the bipolar lead. It is the simple two lead connection. We know that for any electrical potential we need two leads to measure that. So, that is called bipolar lead, and here we have three such configurations. Now, to know that lead 1, lead 2, lead 3 configurations, first we need to look at that how actually it is acquired. It is taken from first of all the left arm one point, then right arm and the left leg, okay. And the right leg, this point actually it is permanently grounded. So, that is the way that the configurations are done. These leads are used for the bipolar lead configuration, and that the connection is not done in the shoulder or in the groin as it is shown in the picture. It is taken from the periphery, or in other words for the two hands it is taken near the leads, so that it becomes easy to collect the data. So, you can take that instead of here it may be taken from the right wrist and the left wrist, the two connections should be there, and near the ankle of the leg the connections are done for the leg. So, these are the points. Now, let us look at that what is lead 1. Lead 1 means that the left arm and right arm, in between these 2 points the connections are made. So, the connections are made between these 2 points for the lead 1, and all the time that right leg is grounded, that is something permanent. So, that gives us to a waveform, we call that lead 1 configuration ECG. Next comes that the lead 2 configuration, where we take it from the left leg to right arm. So, you can take diagonally opposite actually these 2 electrodes, from there it is taken, and lead 2 configuration is the one that what we have used earlier for the explanation. In fact, the lead 2 configuration gives the highest level of signal and it is more known than the other configuration signals. So, that is what the lead 2. The third one is that if we take the left leg and the left arm in between these two, that if we have, and the right leg is grounded all the time. So, then we get the lead 3 configuration signal. Now, as we get actually these signals, they are forming a triangle. The signal vectors also acts in that way. In fact, the heart what we see here, first thing to notice that the heart axis is not vertical, it is making an angle with the vertical axis, and the signal it generates, that is the electrical signal, that actually forms a rotating electric field. You can take that this is rotating electric field. So, at different times you will find that different configurations the value will peak. So, under this influence of this rotating electric field, all these leads can give some signal, and if we vectorically add them, then what we find that lead 1 plus lead 2, lead 1 plus lead 2 means the signals are from left arm to right arm one side, and sorry, lead 1 plus lead 3. So, left arm to right arm and left arm to left leg. So, if we add them together, now it becomes the configurations like lead 2. So, that if we vectorically add that, we can also see that in the graph. So, now this one, as it forms a triangle, that it has been given in the name of the inventor of the ECG signal, Einthoven, and this triangle is known as Einthoven triangle. So, now here in this graph we show that how the ECG signal will look like for different that configurations. We see at the top the lead 1, then followed by lead 2, and then the lead 3 configuration, and that vectorical addition what we told, we can check that in that way. And initial idea was that this triangle, it would be an equilateral triangle. The Einthoven triangle, it was postulated as that a equilateral triangle, all the three sides would be the same, because it is coming out of a rotating magnetic field, and each one of them they are actually making say 120 degree angle with the 0 axis. So, depending on the configuration, they are making lead 1 is making 0 degree with the horizontal axis, lead 2 is making 60 degree, the opposite would have been 120 here. So, 60 degree in this side the clockwise, and 120 degree clockwise by the lead 3. So, that was the initial assumption, but here something actually went wrong in this calculation, primarily because that the human body is not homogeneous, especially for the thoracic region, that what we get, that we have the lung which is filled with air, then spine is there in the moving towards the vertical direction. So, the assumptions of uniformity within the body, that is not actually maintained, and that is why these electrical fields are not actually just a simple rotating magnetic electric field with uniform strength. So, when the people tried to actually add them vectorically, they got a triangle like this, where that lead 1 and lead 2, their magnitude is smaller than this one, that lead 3 configuration. Now, this thing, that this is known as Burger's triangle. Okay. So, that it is given in the name of the inventor who has corrected this error. So, this is known as the Burger's triangle. So, now instead of the Einthoven triangle, we refer to the Burger's triangle. Next, we come for more leads. Now, first thing we should note here, that here we are talking about the unipolar leads. Now, how is it possible with one lead we can measure a potential? Now, here the catch is that there is always a reference lead. However, the reference lead is not a simple lead, it is a composite lead. And how that is done? That if we have multiple actually leads and if we add them up, that can provide us a reference. In all the three pictures you can see that two leads are there connected through two resistance. Now, in between that is center tapped, that resistance is center tapped and we take the reference here. In the next case, here is the reference point. So, that is why, because there is no single point as a reference which is connected to the body, it is called unipolar lead connection. And with that we can have again three configuration. One is lead AVR, that means in this case that right arm, that is the unipolar lead is connected, and reference is the in between the two potentials of the left arm and the left leg. So, in this configuration, the first thing we should note that the primary points from where the potentials are checked, they have not changed. Only thing is changed that how we are connecting them. So, we get first one is lead AVR. This can be, you can say it is some way comparable with lead 1, that where the one point was with the right arm. The second one is AVL. So, here it is from left arm is the single lead is connected, the other two, that is the right arm and that left leg, the midway potential between them provides us the reference. And for the third case AVF. So, AVF in this case that the left feet is the point from where we are taking the connection and the midpoint potential of the two arms, that is serving as a reference. So, let us look at first that how the nomenclature is done. AVR stands for the connection where that unipolar lead is connected to right arm. So, R is taken. The next one, that AVL, that unipolar lead is connected to left arm, and we know out of the two legs only the connection is taken or ECG is taken from the left leg. So, it is marked with F, that unipolar lead is connected to the feet, and all the time that we have that this right leg that is grounded, just like the bipolar lead configuration. Now, we go for another kind of unipolar leads. These are called that unipolar chest leads. Now, when you have that the bipolar leads or that AVL or AVR, this kind of unipolar leads, we are taking the ECG signal from far away of our heart. Now, if we take the signal from far away from the heart, it is very difficult to get that which part of the heart is contributing how much there. We get actually the resultant of the full heart there. So, that though it can suggest that there is some problem there, and that can be depicted as a change in the morphology by looking at that the bipolar signal, you will not be able to find out that what is the origin of that problem. If you have to find that thing more carefully, then you need to come closer to the heart. And in this case, what is done, that this unipolar lead configuration or the chest lead configuration, the right feet it is grounded like previous one, the other 3 points, that is left leg, left arm and that right arm, that the leads are connected with that, and the potential we get here after some equal resistance, they are connected through equal resistance, and these points serve as a that this point is serving as a reference here. Now, taking that as a reference, we take different points V1, V2, V3, V4, V5, V6, 6 different points from there the potential is actually recorded. And if you look carefully, you will find it is starting from that other side of the sternum, that right side of the sternum, and moving away, going to completely the opposite side slowly, and these points they are actually in between the two ribs. All these points they are marked, and they are surrounding the heart, and because of that they can get actually the influence of different part of that heart in different leads in a better way. So, this chest lead configuration, it can tell you the problem is in which chamber of the heart. So, that is that unique feature of that, and when the standard ECG signal is taken, so these chest leads are also connected and they are monitored to find out if there is any abnormality in the heart. So, this is a very important point, and nowadays that you get that number of channels they are connected, and you get all of them, and some of the machines they come with automated features where the machine itself can suggest that which signals are not probably normal. So, now let us move forward. Let us go for the second signal, that is electroencephalogram, or in short we call it as EEG. Now, to know that, first we need to know the origin of it. Here we see in the left hand side the picture of a neuron. The neuron, here is the cell body, that this is the cell body, and at the top of it, just like the branches of the tree, we get some offshoots, that is called dendrite. We get the dendrite. The dendrites act as a receiver to this nerve cell, and the signal that comes here, it passes it on through this pipe kind of structure, that is called action, and at the end of it we get some actually the divided the points or branches, looks like the roots of the tree, they are called the action terminals. So, action terminals acts as an actually transmitter, it gives the signal to the next part. Now, how that happens? Whenever we look at the neurons, that usually that the actions and the dendrons, they couple with each other. So, that is called the synapse, and depending on the strength of connection, that we can get that how much coupling is there or what would be the strength of the signal transmitted to the dendron of the next neuron. And here there are few more peculiarities of the neuron that we should look at. Like any other animal cell, it has a neuron that is there in the cell body, but apart from that, if we look at the construction of the axon, what we get, that it is covered with some lipid layer or lipid profile, and this lipid profile act as a insulation. So, wherever the lipid profile is there, that there would not be any electrical activity. That means, when we have told about that action potential through the transfer of ions from the cell to outside and in the reverse way, that is not possible in those region where the lipid layer is there. So, to have the action potential or to allow the reaction, there is a gap in that, and we mark them. They are called as node of Ranvier. In between in the continuous this myelin sheath, there are some gaps where there is no sheathing is there, and that is called node of Ranvier. So, when the signal passes, what happens that from that cell body, the next electrical connection can happen in the next node of Ranvier. So, electrical connections or signals, they jump from one point to the other, and that is how that the signal can actually pass at much higher speed in the neuron. And how the circuit is completed? One part, that ions are flowing through the within the cell here in the through the action, and through the interstitial fluid which is outside the cell, that the circuit is getting completed. So, that is how the signal flows, and the neurons can be divided into three classes. The first class is the sensory one, the sensory neuron. Sensory neurons are actually their dendrites are connected to our sense organs. So, for example, through the skin we get the sensation of touch. So, there are number of actually that neurons whose dendrites are terminated on the skin. So, whenever someone touches us or we touch some other object, so that sensation comes to the dendrite and passed on to the neuron, and that signal goes to the central nervous system. In central nervous system, there are number of actually signals or number of neurons, they are connected with each other, and those neurons are called interneurons. So, they help in making the decision. Now, once the decision is made, that command comes. Sometimes it could be autonomous kind of decision. For example, if we touch a hot body, immediately our hand or leg will recoil, will take it back. So, that is an autonomous action, or it could be a conscious choice that we have touched the wall, we want to step back. So, all such signals come through the motor neuron. So, motor neurons are giving back the signal or giving the command to the muscles, and interneurons are taking the decision. Thank you.